Hello students, so today we are going to discuss about the balancing of chemical reaction. So in this case we have four different reactions asked to solve in our exercise. But one of the reaction, it contains basic medium, so it will be more better to use basic reaction, because in basic reaction first we have to balance it just like acidic medium, and then later we have to add OH minus ion, so it has one extra step. But the reaction mentioned here, it is already mentioned in previous examples. It's discussed in problem 8.10, so we are not going to repeat it again. So let's discuss the reaction of H2O2 plus Fe2 plus produces Fe3 plus and H2O via both of the methods. So first thing we have to mention the oxidation state of each atom. So hydrogen will be in +1 oxidation state. This is hydrogen peroxide. So in peroxide, oxygen shows -1 oxidation state. Fe is in +2, Fe is in +3, and in water molecule, hydrogen will be in +1, oxygen will be in -2 oxidation state. So which of the elements actually participates in oxidation and reduction method? So hydrogen is present as spectator ion because it do not change oxidation state. Oxygen, it was in -1 oxidation state, later it has -2, so it is reduced. Fe, it is +2 to +3, that means it is oxidized. So in both of the reaction, this first step will be common. First we need to write the skeletal equation, and then we have to mention their oxidation state. So in both of the reaction or methods, this step is common, and now we are moving to the difference. So first let's discuss the oxidation number method. So this whole reaction has oxidation of Fe2 plus into Fe3 plus and reduction of H2O2 into H2O, or oxygen from -1 to -2. So now we have to balance the atoms which changes oxidation state. So oxygen, before reaction we have two of it, after reaction we have only one. So let's place 2 before the H2O. So now we have two oxygens on both side. Before reaction Fe, it is 1, after reaction it is 1, so no need to worry about it because it has similar quantity. Now change in oxidation state. For peroxide, one oxygen changes from -1 to -2. That means for one oxygen change is equal to 1 electron, but we have two oxygens, so total change is equal to 2 electrons in reduction reaction. For oxidation reaction, from +2 to +3, that means we have change is equal to 1 electron. So that's why we have to equalize the number of electrons in both reaction, and for that we have to multiply the oxidation reaction with 2. So we have to put 2 Fe2 plus, it produces 2 Fe3 plus. Now we have similar number of electron transfer. Now we have to balance the charges on both sides. So let's calculate the charge first. H2O2, it is neutral, so total it will produce 0 charge. Fe2 plus carries +2 charge, and we have 2 of it, so +4 charge. Later we have 2 Fe2 plus, so 2 into 3 it will give us +6 charge, and H2O, it is neutral, so it will give us 0 charge. So before reaction we have +4, after reaction we have +6 charge. And we have acidic medium, so we can put H plus and H2Os. So we have to balance the charge, and to balance the charge we can add 2 H plus before the reaction. So total charge +4 plus 2 is equal to 6. So we have similar charges on both sides now. Now last thing remained is we have to check the balanced equation. That means if all the atoms are in equal quantity before and after reaction, all the charges are equal or not, all the spectator ions, that means in this case hydrogen and oxygen, they are balanced or not. So let's check the quantity of hydrogen and oxygen first. So before reaction we have 2 plus 2, that means 4 hydrogens, and oxygen actually do participate in redox reaction, so it is already balanced, so no need to check it again. Later after reaction we have 2 into 2, that means 4H. So all of the elements, spectator ions or reduced and oxidized couples, are already balanced. So that means this is our balanced chemical equation. H2O2 plus 2Fe2 plus 2H plus, it gives 2Fe3 plus 2H2O. Now in second method, we have to split the reaction in two parts: reduction half reaction and oxidation half reaction. So we already know the oxidation states. For H2O, H2O2, our change in oxidation state is -1 to -2, so it is reduction reaction, and for Fe it is +2 to +3, so it will be oxidation reaction. So let's separate these two half reactions. Now we have total two oxygens on the left hand side in reduction half reaction and only one in right hand side. So we have to balance the actual participant in redox reaction. So that's why we have to put 2 before the H2O. So now we have two oxygens on both sides. In case of reduction oxidation half reaction, we have one Fe on both sides, so it is already balanced. Next thing will be the balancing of elements which do not change their oxidation state. That means spectator ions. So before reaction we have 2 hydrogens. After reaction we have total 4 hydrogens. So that's why we have to put 2 H plus before the reaction, because we have acidic medium. That's why we can put H plus and H2Os. In oxidation reaction we do not have any hydrogens and oxygen, so no need to balance it. Next step is to balance charges. So before reaction charges H2O2 it is neutral and 2H plus, that means +2 charge. After reaction 0 charge. So we can put electrons, 2 electrons on reactant side. So we get -2 +2, 0 charge. And again this is reduction, so in reduction we put electrons on reactant side. So change in oxidation is from -1 to -2. That's why one oxygen accepts 1 electron. We have 2 of it, so it will accept 2 electrons. So this is our balanced half reduction reaction. Now on oxidation half reaction we have +2 charge on the reactant side, +3 charge on product side. And as we know, in oxidation electrons are released, so released electrons will be put on other side, that means right hand side. So one Fe releases 1 electron, and now total charge is also balanced, +2 on each side. On the reduction reaction we have 2 electrons. In oxidation reaction we have only 1, so we have to multiply oxidation half reaction with 2. So you will get 2 Fe2 plus produces 2 Fe3 plus 2 electrons. Now we have 2 electrons on both sides. So that's why our both of the half reactions are completely balanced. And last step will be addition of both of the reaction into each other. So let's add these two reactions together. So you will get H2O2 plus 2H plus 2 Fe2 plus 2 electrons. Okay, and on the other side you will get 2 Fe3 plus 2 H2O plus 2 electrons. So electrons are common on both sides, so it will be cancelled out, and we have the balanced equation H2O2 plus 2H plus 2 Fe2 plus, it produces 2 Fe3 plus 2 H2O. So this is our balanced equation according to oxidation reduction half reaction.